2021 Grade 10 AMC 10A Fall Questions 11 through 20. Emily sees a ship traveling at a constant speed along a straight section of the river. She walks parallel to the riverbank at a uniform rate faster than the ship. She counts 210 equal steps walking from the back of the ship to the front. Walking in the opposite direction, she counts 42 steps of the same size from the front of the ship to the back. In terms of Emily's equal steps, what is the length of the ship? Let's first draw the first scenario, which is basically a comparison of the ship, which goes along here, to Emily, who goes along here, parallel. And I'll just draw the ship at the very end of its path right here. And they're basically saying that Emily travels 210 steps, equal steps. Okay. And then the second scenario is similar in the sense that they're both going in the same direction initially, but then Emily starts walking in the opposite direction. So let's say this is sort of the end point of the ship here, right here. Now the ship's going to keep traveling that way, so the ship's going to kind of be going like that. But Emily's going this way. So she's going to go till this point right here. The point right there. So this is sort of Emily's journey. And that journey, they're saying, is 42 steps. 42. Okay, so then we have to use our standard formula. Speed is equal to distance over time, or any variation. For example, time is equal to distance over speed. And try to figure this out. So the ship and Emily both travel at a constant rate, I believe. Yeah, constant speed, both of them. So that means we can definitely use this formula. So here we go. Now, because they're traveling at a constant speed, we can use ratios of these two different scenarios. So for example, this first scenario right here, we have 210 here, but this segment, if let's say we let the ship be x in terms of its length, that segment would therefore be 210 minus x in terms of its distance. In a very similar way, this over here, right here, I have labeled as 42, but this right here, if you just look at the ship, would be x minus 42. Actually, it should be right here. This we're pointing right there. Sorry, this segment right there, x minus 42. Okay, so now the ratios, if you look at right over here, 210 for the Emily and 210 minus x for the ship. And the ratio on this scenario, Emily is 42 and the ship is x minus 42. We're doing a ratio of the distances. And because they're traveling at constant speeds, these ratios would be equal. So we set them equal like that. And then we can have the basic algebra formula that we can solve. So solving, cross-multiplying, let's see here, that's 1, that's 5. So this is going to be 5 times x minus 42 is equal to 210 minus x. 5x minus 210 is equal to 210 minus x. And that looks like 420 is equal to 6x. And therefore x is equal to 70. So the answer to number 11 is A. The base 9 representation of the number n is 27006000052 to the base 9. What is the remainder when n is divided by 5? So 27006000052. Okay, and this is of course base 9. All right, well, in base 9 or any base, this would be to the power of 0, 9 to the power of 0, 9 to the power of 1, 9 to the power of 2, and so on. So I will just write out the exponents first, and then we'll try to figure out what this actually is. So this number here in base 9 would be 2 to the power times 10 to the power, 2 times 9 to the power of 10, plus then 7 times 9 to the power of 9. Just got to make sure we don't make any mistakes. We don't have to worry about this or that, but we have to look into that 6. That's going to be 6 times 9 to the power of 6. And then looks like we don't have to worry about all those, but we have to include that. That's 5 times 9 to the power of 1. And then finally, 2 times 9 to the power of 0. So that's basically the number. Okay? So now what we have to do is look at it from the perspective of mod 5. So what is the remainder when divisible by 5? Now, these are very large numbers here, so I'm not going to calculate them. What we can do is just look at a pattern. A pattern of what? A pattern of powers of 9. And I'll explain. So 9 to the power of 0 is equal to 1. Now, what is that mod 5? Well, when you divide 1 by 5, the remainder is 1. 9 to the power of 1 is 9. Mod 5 is 4. 9 to the power of 2 is 81. Divisible by 5, the remainder is 1. And so on. 9 to the power of 3 is 729. Mod 5 is 4. And we'll just do one more. 9 to the power of 5 is 6561. Mod 5 is 1. So as you can see, the mod 5s just alternate. 1, 4, 1, 4, 1, 4. So then we can easily sort of figure this out. If you extrapolated this list, you will figure out that 9 to the power of 10 mod 5 is 1. So we'll just put 2, this 2, but then since we're doing mod 5, it would be a 1 here. Similarly, the 9 to the power of 9 mod 5 is 4, which we can get from that list. 9 to the power of 6 mod 5 is 1. 9 to the power of 1 mod 5, well, that one we know from that list, actually. It's 4. And then finally, this is, of course, just 1. So there we go. We got, without too much difficulty, we were able to figure this out. And this is easy now. This, you just crunch out these numbers. 2 plus 28 plus 6 plus 20 plus 2. And that is 58. And 58, if you do 58 mod 5, would be a remainder of 3. And that's it. So number 12, the answer is 3, which is choice D. Each of 6 balls is randomly and independently painted either black or white with equal probability. What is the probability that every ball is different in color from more than half of the other 5 balls? Okay, so this question, the sentence has to be understood very carefully here. So let me give you a scenario. You've got 6 balls, right? 1, 2, 3, 4, 5, 6. And I'll give you a scenario that this works. This one right here. Let's talk about it. Let's see if it works or it doesn't work. If 3 are white and 3 are black, does this sentence hold true? That every ball is different in color from more than half of the other 5 balls. Okay, let's concentrate on this one. This is a white ball. Is it different in color from more than half of the other 5 balls? Well, here are the other 5. More than half of those 5 would be 3 or more, right? Is it a different color than more than half? And the answer is yes, because there's 3 that are black and 3 represents more than half of the other 5. So that sentence is a little tricky to figure out. And if you were to go through different scenarios, this is the only scenario in which this sentence holds true. It was kind of interesting, right? You think, well, really? What about if you had, let's say, a 2-4 split? So you have 2 white and you have 4 black. And then you've got this one. And then you just look at these 5. isn't this also true that this white ball is different in color than more than half of the other 5? Sure. But remember, every ball, this has to hold true for every ball. In this scenario right here, if we concentrate on this ball, then it's no longer true because this ball is black. Is it a different color than more than half? No, because if you look at the other 5, only 2 are a different color, and 2 does not represent more than half of those 5. You see what I'm saying? So this scenario is the only one. You got to have 3 white, 3 black. Okay, we can figure out the probability. Probability is almost always a fraction. The top number is our specific condition. Specific condition, and our bottom number is the total. So let's talk about the total first. Well, the total is easy because for each of these balls, we have 2 choices, white or black, and that's it. So in order to get the total, you just multiply them. So it's really 2 to the power of 6, which I believe is 64. Okay. Now, specific condition, we're going to choose notation because we are interested in this scenario and only this scenario. So basically that means that from 6 balls, you choose 3. You can choose 3 white or you can choose 3 black, but from 6, choose 3 to be white. And if you do that, then that pretty much creates the other scenario. Because if you choose 3 to be white, the other 3 are going to be black automatically. And that's really all there is. And then when you crunch out these numbers, you guys know how to calculate choose notation, so I'm not going to go through that. This ends up to be 20 over 64. And in lowest terms, that's 5 over 16. So number 13, the answer is D. How many ordered pairs x, y of real numbers satisfy the following system of equations? Okay, so we've got 2 equations and we have a choice. Either we solve this algebraically or we create a graph. And I think the graph system is a lot easier to explain. And it's not actually not that difficult to create. They're just asking, yeah, how many ordered pairs satisfy? So basically just looking for the number of intersection points, the number of solutions to that system of equations, and it's 5. So the answer to number 14 is D. Graph. So first what you do is you break those up. You have the first one, right? X squared plus 3y is equal to 9. Put it into a format to make it look like a parabola. And when you rearrange it, it becomes this. And you guys know how to graph that. That's fairly straightforward. You can easily graph that. And that's what they have here. This parabola right here that I'm doing a terrible job of tracing. So that is the parabola. I'll just trace the bottom here. I don't want to get the middle stuff mixed up, but that's the parabola. Okay, now what are these boxes here? These boxes represent the other equation, which was x factorial plus y, factorial, absolute value. Wow, it's definitely not factorial. All squared is equal to 1. Now, what you do is you got to break this up a bit. And you take the square root of both sides, and when you do, you get absolute value is equal to either plus or minus 1, right? When you take the square root of both sides. And that leads to 2 equations. We have the first one, which would be equal to 3, and then the second one, which would be equal to 5, I believe, right? Yeah, 5. Okay. So this first one is the inside box. I'll just draw a line right there. And the second one here is the outside box. So if you guys have a little bit of practice of graphing equations that involve absolute values, then it shouldn't be that hard for you to graph those 2. And then once you graph them, really what you're looking for is intersection points. Intersection points of these graphs. So where do they connect, if at all? Okay, well, let's see. Where does this graph connect with either this one or this one? Okay. Well, the parabola looks like it connects right there. Intersects, I guess that's a better word to use. There's another intersection point, and there's another intersection point. And that one was with this one. Now, it also intersects here and here with this equation. So there you go. You've got 5 intersection points. And I think that's all they asked for, right? Isosceles triangle ABC has AB and AC equal to 3 root 6, and a circle with radius 5 root 2 is tangent to the line AB at B and to the line AC at C. What is the area of the circle that passes through the vertices A, B, and C? Okay, so the first thing in this question is we've got to create a graph, or a diagram, basically. What do they want? What is the area? Okay, so go back to the question, and that is choice C for number 15. And here's the diagram. So all I've done is shown you a diagram of what the question says. So nothing has changed. Just putting it in a picture, so it makes it much more clearer. Okay, so we have to talk about a few things here. This I here represents the center of that circle. This O represents the center of the other circle. This 90 degrees is so because these are tangents. That's a tangent point. Okay? And this right here, this 90 degree angle here, right there, that is 90 degrees because O is the circumcenter of triangle ABC. And then another thing is that we have a perpendicular bisector of a chord here. See, this is a chord from B to C, or B to A down here, all the way down here you see A. That line connecting B to A is a chord, and this line connecting O to D, that is a perpendicular. OD is a perpendicular bisector of chord AB. So because it's a perpendicular bisector, it cuts it in half, and that's why we have these symbols to show that A to D is equal to D to B. Okay, so those things have to be explained. All right, so now because of all of these things, we have a similar triangle situation. That triangle ADO is similar to triangle ABI. ABI. Okay? ADO is similar to triangle ABI. And that should be fairly obvious once you understand, the things I just explained. So here we go. We got ratios. AD over DO is equal to AB over BI. And we can rearrange this a little bit, that AD over AO is equal to DO over BI. Or any way you want to arrange it that helps us a little bit. I think if I put this should be, I think I was right. This was AB, sorry, not AO. Let's see if I did this correctly. Yeah, I did it correctly. Okay, AD over AB. Now, AD over AB, because of this rule, is really just a half. Right? This right here, because AD is half of AB. And then DO over BI, that one I will need to figure out. So let's see here. How can I figure that out? DO over BI. Well, DO I don't know, to be honest. BI, I believe, is the radius, right? Yeah, that's just the radius. So they've already given you that in the question. So that's 5 root 2. Okay, great. So we can figure this out, actually. This can be figured out pretty quickly. It's 5 root 2 over 2. Okay, so we figured out the radius of that other circle. So they want you to figure out the area, right? Yeah. Hold on, let me check. That shouldn't be that big of a deal. Let's figure out the area. To figure out the area, I'm going to need to know the radius, meaning of the other circle, which is from O to A right here. I'm going to need to know that. So I'm going to have to incorporate this triangle into my calculations by using Pythagoras. So if this is 3 root 6 from A all the way to B, A to D is going to be half that. So it's going to be 3 root 6 over 2. O to D, or DO, I just figured out, was 5 root 2 over 2. So then I can use Pythagoras to figure out OA. All right. So OA squared is going to be AD squared plus OD squared, right? Basic Pythagorean theorem on that triangle, right triangle. Okay, so AD is 3 root 6 over 2 squared. OD is 5 root 2 over 2 squared. And put this all into the square root to figure out OA. And when you crunch out these numbers, I'll let you do that. You get root 26. Okay, so now we can figure out the area of that triangle. Area, of course, is pi r squared. R, we just figured out, is OA, which is root 26. So root 26 all squared, and that is 26 pi. So 26 pi is our answer. Problem number 16. The graph f at x bracket absolute value minus 1 minus x bracket absolute value is symmetric about which of the following? Here, x bracket is the greatest integer not exceeding x. So if you're not familiar with x bracket, and I put, let's say, a number like 5.2 in the bracket, what would that be equal to? Well, according to the definition, it's the greatest integer not exceeding. So that would be 5. See what I mean? Okay, so the way to approach this is to do a graph of this, and then subtract the two graphs and see what you come up with. And this is actually, so that's what they're really asking for. This graph right here is symmetric about which of the following, and it's the point half 0. So that's actually a very time-consuming question. In my opinion, quite challenging, especially on a math contest where you have very limited amount of time. You know, they have not made this easy. So this graph up here, the one that is in red, represents the graph of f at x is equal to x bracket absolute value. And then this green one represents, let's say we'll call it g at x, is equal to 1 minus x bracket absolute value. And if you in a painstaking way, kind of plug through values, you'll find that this is what each graph looks like. And pay close attention. The solid dots, like when it's colored like that, means it includes that point. And then when it's circular without being circled in, that it does not include that point. It approaches it, but it does not include it. And in a very similar way, that has kind of a similar look to it. Then what you have to do is you have to subtract them. So remember, it was f at x minus g at x. So it would be x bracket absolute value minus 1 minus x bracket absolute value. That's the graph that is represented here. And when you go through point by point, you can see that you will arrive at this one. Now they're asking this graph right here, what is it symmetric? What point is it symmetric around? And when you look at this graph, it will be symmetric around this point right here. Let me write it in red. Right here. That is the point that represents where the graph is symmetric about. And that point on the graph is a half for the x-coordinate and 0 for the y-coordinate. Problem number 17. An architect is building a structure that will place vertical pillars at the vertices of hexagon ABCDEF, which is lying horizontally on the ground. The 6 pillars will hold up a flat solar panel that will not be parallel to the ground. The heights of pillars A, B, and C are 12, 9, and 10, respectively. What is the height in meters of the pillar at E? We got the answer to number 17. The answer is 17, and that is choice D. This is the reconstruction of what's in the question in a diagram. So we have to figure out the height at E. Okay, so right here, what is that height going to be? All right. So when you look at this graph, there's a few things I want to discuss first before I jump into the calculations. The height increase from C to D. So as you go from C to D, right? So from this point right here to this point right here. I don't know what, well, this height we know is 10, right? But the height of D I don't know. But as you're going from C to D, it's increasing, right? The height is increasing. That height increase from C to D is the same as the height increase from A to F. So the height of A is 12, but as you go from this point right here to this point, it increases in the same amount as when it went from C to D. Okay? So that's because this is a hexagon that's regular. It's a regular hexagon. In a very similar way, we can conclude that the height increase from A to B, or actually we're going from height decrease this time. So we can, whatever, you can say the height increase from B to A. So height increase from B to A, as you're going from here to here, is the same amount as the height increase from D to E. So as we go from this point to this point, it'll increase by the same amount because it's a regular hexagon. Okay? So let's say, do we know any of these? I think the only one we know, or the only one we can figure out, is going from B to A, right? Because the height of B is 9 and the height of A is 12. So as you go from B to A, you increase by 3. And therefore, when you go from D to E, you would also increase by 3. So that is all we know. Now D, we don't know the height, so I'm just going to label the height something. I'll label it X. So X is the height from D all the way up until this point right here. And therefore this point, the height of E will be X plus 3. Okay? And that's all I know so far. The height will go up to X plus 3. Okay. All right. All right, without messing up this diagram too much, let's see if I can sort of make some comparisons. The height is X here, right? So it's going to be X up until there, but up from here to there, that's 3, since that's X plus 3. Let's see what else I can do. The height till here is 10, so that's going to be 10. So therefore, this is going to be X minus 10. Okay, I think that's all I can do there. Okay, so now we have to make one final comparison in order to figure this question out. But that one final comparison may not be that obvious to you if I write it out. So I have to explain it first. And we have to explain it with the diagram of a regular hexagon. So there we go. There's a regular hexagon. And I've got to explain this in a way that involves these letters. So this is going to be B right here. This is E. Okay, we're sort of looking at the plane, the red plane. So I'll just write red plane right here. But even though they're labeled A, B, C at the bottom, I'm labeling the tops correspondingly. So this is F, and this is E, and so on. Okay? So we got B, we got E, and then we've got whatever D, C over here, and F and A over here, right? Okay. Now I have to convince you that the distance from D to C is half the distance from E to B. So for example, if this is Y, E to B is 2Y. Now you say, well, okay, but I'm not convinced. Okay, no problem. That's my job, to convince you that it is half, and therefore we can proceed with the question. Well, it's a regular hexagon, so that means that all the sides are the same, right? So we'll just call it Y. And then because it's a regular hexagon, all the angles are the same. So the angle, the internal angles, like that's an internal angle, if you calculate it, it'd be 120. So if you cut a line down the bottom, top to bottom like that, this angle will be 60. And this is a right angle, so this is 30. So we have one of those 30, 60, 90 triangles. And as you know, the ratio of the sides of a 30, 60, 90 triangle are 1, 2, and root 3, right? So the same kind of story down here, it would be pretty much identical, 2, 1, and root 3. And since this side is the same as that side, this is 2, and this is 2. So the distance from here to here looks like 1, 2, 3, 4, and the distance from here to here is 2. So as you can see, I hopefully proved that if that's y, the distance from here to there is 2y. Okay. All right. So now that you have been convinced of that, we can go back to the question. If you go back to the question, basically what I have to show you now is that if you go from B to E, so you're going from there to there, that is twice going from C to D, which is right here, which is exactly what I proved over here. So if you're going from B to E, that is going to be twice going from C to D. Okay, so if we go from B to E using our formulas, we got x plus 3 minus 9, right? So x plus 3 minus 9. And then that's going to be twice going from C to D. So that's x minus 10. X minus 10. Okay, well, that's pretty straightforward. After all this, we finally get to something that we can do without too much trouble. So what's that? X minus 6, 2x minus 20. So x is equal to 14. Okay, x equals 14. Now, what do they want us to figure out? The height at E, right? So if x is equal to 14, E was equal to x plus 3. So that's 14 plus 3, which is 17. There we go. A farmer's rectangular field is partitioned into 2 by 2 grid of 4 rectangular sections as shown in the figure. Each section the farmer will plant one crop: corn, wheat, soybeans, or potatoes. The farmer does not want to grow corn and wheat in any two sections that share a border, and the farmer does not want to grow soybeans and potatoes in any two sections that share a border. Given these restrictions, in how many ways can the farmer choose crops to plant in each of the 4 sections of the field? All right. So this is one of those very time-consuming questions, and I'm just going to go through the scenarios, and I am not going to go and explain every one like in exhaustive detail, because you don't want to hear me go through every single scenario and why all the different combinations. That's just but that's just painful to hear. So I'll just go through the 5, and I'll let you figure it out. So the first scenario is when you have all 4. So for example, I'm just going to call them C, W, S, and P, right? For corn, wheat, soybeans, and potatoes. So you're choosing all 4. So you have one section with corn, one section with wheat, one section with soybeans, and one section with potatoes, right? So that is one of those scenarios. But you think, we also have to take into consideration that you can't grow corn and wheat in any two sections, and we can't grow soybeans and potatoes in any two sections. So if we arrange them, corn and wheat have to be opposite like that. See what I mean? And therefore, the soybeans and potatoes would have to be opposite also. So that's one such way of doing it. And there are 8 different ways of arranging these 4 that fill the criteria of the question. And you guys can figure out what are the 8. It's not that hard. I just don't want to have to go through and draw every single one, because that's going to be way too time consuming, and you don't want to hear me do that either. Okay. Now let's jump to the last one, which is when all of them are the same. So for example, all of them are corn or all of them are wheat. Well, there's 4. There's 4 ways of doing that. So actually it's probably better for me to write the total up here. So there's 8 ways of doing that. 4. You can have either all corn, all wheat, all soybeans, or all potatoes. Those 2 are relatively easy. These 2 are relatively easy to sort of understand. Okay. Now things start getting a little bit complicated. Now we have a scenario where you have 2 of the same. So for example, corn, 2 of these sections are the same. But then we have one different, like wheat, and then one different again, like soybeans. And an example would be something like this, CCSW. Remember, the C and the W cannot be sharing a border, and therefore they have to be opposite, like diagonal like that. And then the other C I put in the top right, and the soybeans I put in the bottom left. This is just one. And if you go through this, there's 16 of these. Okay? So it's your task to sort of figure out how to figure out 16. And it's not that difficult, to be honest. I just not going to draw them all out because that's too time consuming. The third is if you have 2 of the same and then 2 of the same. So for an example of that would be 2 corn, 2 soybeans. So something like this, CCSS. That's just one example. And of course, you can have other crops where you have 2 of one, 2 of the other. But what's interesting of these is you could never have, for example, 2 corn and 2 wheat, right? Because 2 corn and 2 wheat, you'd never be able to put them together because of that rule that they can't share a border. So that is something that limits your variations, and there's 24 of these. And then finally, the last one is if you have 3 of the same and 1 different. So for example, C, 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 and then P, like that. And when you do the different possibilities there, it's 32. And then, of course, you add all these up, and when you do, you get a grand total of 84. So another time-consuming question, and that's C for the answer. Problem 19. A disk of radius 1 rolls all the way around the inside of a square of side length S greater than 4 and sweeps out a region of area A. A second disk of radius 1 rolls all the way around the outside of the same square and sweeps out a region of area 2A. The value of S can be written as A plus B pi over C, where A, B, and C are positive integers and B and C are relatively prime. What is A plus B plus C? This question, excellent question by the way, the answer is 10, and that would be A. The best way of explaining this question is with a diagram, and that's what this is. You've got the square here in the middle, in the black border. You've got the red that represents the inside sweep and the green that represents the outside sweep. And we are told that we have to figure out the value of A. Okay, so let's talk about this. First, let's talk about the inside sweep, so the inner sweep that is represented by the red. Okay, So I think we're going to have to break this up a little bit. And when we break it up, it should be a little bit more digestible. The radius of this circle was 1, correct? So the diameter, therefore, is 2. So if the circle is all the way from here to here, then that's an area of 2. And similarly, the circle would also be from there to there. Now, the full length of that square is s. So therefore, from here to here would therefore be s minus 4. So the first thing is the area of that inner square is s minus 4 squared, right? The side squared. So we'll put it all together, but I'm just trying to explain each component. Now, the next one component is this little part here, that corner. So that corner, if we were to draw it out, it's kind of like this, right? And the corner is calculated by considering the fact that it is part of a box where the other part is a quarter of a circle, correct? So that's very useful if you can kind of envision it as a box with a quarter of a circle taken out of it. So how do you calculate that? Well, what is the radius of that circle? Remember, it was 1. So this box, this is also 1, is really a 1 by 1 box. 1 times 1. And then you're going to subtract from it the area of a quarter circle. So a quarter times pi r squared, where r is 1. So there you go. So that 1 times 1 is 1, and this looks like pi over 4. Okay, so that is the area of that region that we can kind of call the corner. But there's 4 of them, right? There's one corner here, one corner there. There's another corner here, another corner here. So 4 corners. So we have to take this and multiply by 4. And when we do that, we get 4 minus pi. Okay, so we've got the inner box, we've got the 4 corners. Okay? So now we can figure out the area of that red region. The inner sweep would therefore be the full square, which is s squared, since the side is squared, minus the inner box, which we figured out was s minus 4 squared, here, minus the corners, which is 4 minus pi. And there we go. That is the area of the inner sweep, and they are saying that represents A. Okay, great. Now what we do is the same kind of thing for the outer sweep, or outer, whatever you want to call it, region. And here we go. So now we will concentrate on the outer sweep, or outer region. Okay, so the outer region hopefully won't be that difficult. Let's again break it up. Let's see here. We've got to sort of create a scenario like that. And in a very similar way, we're just kind of partitioning to make this easier here. Like that. And then the bottoms are going to be similar. Okay. So the outer one is not going to be too difficult because remember that certain things we can just look at in terms of shapes. So for example, this shape right here, that's just a rectangle. And its dimensions, well, this is S. And this dimension from here to here, well, that looks like it's just the diameter of the circle. And the radius was 1, so the diameter is 2. So that is just 2 times S. And there's 4 of these, right? 4 of these rectangles. So if each is 2 times S, 4 of them would be 4 times 2 times S. And that is 8S. So that takes care of those rectangles. Now we have to calculate the areas of these, what looks to me like, they look like quarter circles basically. So there's 4 of them, and each one is a quarter circle, so 1/4 pi r squared. But what's the radius? Well, from here to here is the radius of that shape, and that's 2. And that's it. So 2 goes in there. So that looks like 4, that just looks like 4 pi to me. So the outer sweep, which they have called 2a, looks like this 8s plus this 4 pi. And that's it. So now we've got a, we've got 2a, and we can equate them. So here we go. 8s plus 4 pi is equal to 2a, and a is equal to s squared minus s minus 4 squared minus 4 minus pi. Okay, so this should be fairly straightforward to calculate. Okay, so now we just have to do this algebra here. All right, so I'm going to take that one. I'm going to divide it by 2. So that'll just give me 4s plus 2 pi. And that'll be a. And then this a I'll just stick over here since they're equal. So s squared minus, I'll expand it out, s squared minus 8s plus 16. And then minus 4 plus pi if you take it out of the brackets. Okay, so let's see what we can do here. The s squareds cancel, and then we get 8s minus 16 minus 4 plus pi. Nothing over here has changed. Let's calculate this now. So this becomes 4s pi minus 20. And then we're solving for s, right? So we got pi plus 20 over 4 is s. And I think we can reduce this to lowest terms. 20 over 4 is 5 plus pi over 4. And they're saying that the final format of this is that s is equal to a plus b pi over c. Okay, well, a little bit tricky. That means that this is a 1, even though you don't put the 1 in, right? But that's what b represents. So that means a is 5, b is 1, and c is 4. And they wanted us to figure out a plus b plus c, and that is 10. So problem number 20. How many ordered pairs of positive integers bc exist where both x squared plus bx plus c equals 0 and x squared plus cx plus b equals 0 do not have distinct real solutions? So before we solve, we have to explain something called the discriminant. Concentrating on this part of the sentence. Do not have real or distinct. Well, let's just talk about do not have real. Do not have real first. Let's just talk about that. Do you remember the quadratic formula? If you have ax squared plus bx plus c is equal to 0, then x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. You guys remember that, right? If I even wrote it properly. The discriminant is right here inside that radical. If something does not have real solutions, what that basically means is that the discriminant is less than 0. So it means that b squared minus 4ac is less than 0. Right? Because it would therefore be a negative number, and you really can't have the square root of a negative number. If you do, it's not real. It's an imaginary. Now let's talk about the distinct word. Do not have distinct. What does that mean? Well, distinct means two, right? If you have A and B, they're different, right? If they do not have distinct, that means they're both the same. And if they're both the roots are the same, then that means that b squared minus 4ac is equal to 0. That way you would just get that as a root. Got it? So if we put these two things together, really what we're saying is we want b squared minus 4ac, the discriminant, to be either less than or equal to 0. Okay, so that needs to be explained instead of just saying that and then moving forward. Now, let's apply that to both of those equations. So for the first one, be careful we don't get confused with the lettering. It would be b squared minus 4 times 1 times c is less than or equal to 0. Applying it to this equation. And therefore, that's b squared minus 4c is less than or equal to 0. B squared is less than or equal to 4c. Okay, great. Now let's do the same thing for that equation. And that would be c squared minus 4 times 1 times b is less than or equal to 0. C squared minus 4b is less than or equal to 0. C squared is less than or equal to 4b. And I think that's all right. So we got to combine these, and then hopefully it will help us figure this out. Okay. So I got to combine this and this. Now, right now they don't look identical, but we can make them look very similar, right? So we can make them look very similar. How? I think by multiplying. Well, first, let's do a few things here. First, let's square this guy. So b to the power of 4, and then this becomes 16c squared. And then multiplying this guy by 16. And that would make it very similar. Okay, now we can combine. Okay, good. All right, let's combine that now. So that means 16c squared is less than or equal to 64b and greater than or equal to b to the power of 4. Okay. And then now we have to just sort of substitute values because we're told that they're integers, right? Positive integers? Yeah, positive integers. So we can just sort of substitute in positive integers and see what we get. It shouldn't be that difficult. So let's try. Let's start with b, and then the smallest positive integer is 1. So let's see what happens. We try b equals 1. We get 1 is less than or equal to 16c squared is less than or equal to 64. And this gives us solutions for c of c equals 1 or 2. Okay, let's try b equals 2. That would make this 16 is less than or equal to 16c squared, less than or equal to 128. And this gives me solutions of just 1 and 2 again. Try b equals 3. And this gives me 81 is less than or equal to 16c squared, less than 192. This gives me a solution of just c equals 3. And then b equals 4. That gives me 256 is less than or equal to 16c squared, less than 256. Yeah. And that gives me a solution of just c equal to 4. And that's it. And then if you keep going, you'll find you won't get any more. So how many ordered pairs do we get? Over here we got 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, and 4, 4. So it looks like we got 6 ordered pairs. So 6 ordered pairs BC, and therefore, number 20, the answer is B.